Quick review of what we did in class. Now, start off with the problem of graphing y equals x minus 2 times x plus 3. And my advice was to start by finding the intercepts. Found that most people didn't know what intercepts were, which is a little worrisome, but let's clarify it. As we've seen repeatedly, an x-intercept is where y equals 0. A y-intercept is where x equals 0. Once given this information, people pretty quickly were able to find the x and the y-intercepts. So that was pretty good. You can just do this by inspection, of course. Y equals 0 means that y is 0, which means that this product is 0. And that'll occur if this is 0, and it'll also occur if this is 0. This is 0 when x equals 2. This is 0 when x equals negative 3. So if x equals 2, you have 0 times whatever this is, turns out to be 5, and that gives you 0. And if x is negative 3, then this is 0. You'd multiply it by this, which turns out to be negative 5, but it doesn't matter. This is 0. It makes the whole product 0. So that either x equals 2 or x equals negative 3 will give you y equals 0, meaning that the x-intercepts occur at x equals 2 and x equals negative 3. The y-intercepts occur when x equals 0. Now that's actually very easy. You just plug in 0 for x and you get negative 6. So that, and I haven't written that one down here. We'll see that on another board shortly. The point I want to make here is now, more generally, because some people said things like, well, you just reverse this number and you reverse this number. That's great, but it's not going to work in general, reversing the number, because you don't always have 1 in front of the x. If it's just plain old x, you can do that, but that's not something you can build on. What you have to do is you have to say, well, for this product to be 0, either this number has to be 0 or this one does. So that gives us two equations. We set this equal to 0, x minus 2 equal to 0, and we set this equal to 0, x plus 3 equals 0. So that we see that this is 0 if x minus 2 is 0, or if x plus 3 is 0. We can solve those equations, and they're very easy to solve. We get x equals 2, we get x equals negative 3. So there are the zeros. And the general procedure is going to be to write the equations you have to solve to get the zeros. Now, having solved this introductory question, and let me put something else up here, at least for a minute. We actually approached this problem twice. This board's very precarious. It could fall off at any time, so you can root for that if you like. Okay, again, same question, same information. We listed the intercepts, and once you have those intercepts, you can easily graph them. Okay, x-intercepts are negative 3 and 2, as we saw, so we put dots at x equals negative 3 and 2 where y equals 0. Also, if x equals 0, y equals negative 6, that gives us the y-intercept 0, negative 6. And I'm not sure the camera goes low enough to see that. So another thing we know is if we multiply this out, we get a quadratic function, so we know that this is a quadratic function, therefore its graph is a parabola. And another observation we want to make is if you're given a quadratic function, and if you can factor it like this, then it's very easy to find the zeros. Of course, the intercepts are easy to find in any case. Okay, we continued on with a question regarding this function. Now, there was a sequence of questions that broke down the process of understanding the intercepts and asymptotes and so forth for this function. First, we consider the numerator. So the numerator has zeros when this is 0 or when this is 0. Okay, well, we write down this equal to 0, we write down this equal to 0, and we solve it. What are our solutions? X is -3/4 or -0.75, and X equals -1. Now, these are very easy to solve. You should solve them. You should have paused and solved them in the first place. You should always pause and try to do what I'm about to do. Okay. Of course, you don't always know what I'm about to do, so it's not always feasible. So there are the numerators. They have zeros here. It has zeros here. The zeros of the denominator are found equally easily. You get x equals -1/2 by setting this equal to 0. X equals -6 by setting this equal to 0. So running out of space here. But it's at x equals -1/2 and -6. Okay? Now, we ran into some problems interpreting what happens when the numerator is 0 or close to 0, when the denominator is close to 0. So it should be clear that if the numerator is 0, then unless the denominator happens to also be 0, the y value is 0. So numerator 0 implies the y value is 0. Now, if the denominator is 0, that's undefined because you can't define division by 0. So we ask the question, what happens if the denominator is just close to 0? For example, if x is -6, we get a 0 here, which makes the whole denominator 0, which makes everything undefined. So this value of y isn't even defined if x equals -6. But if x is close to -6, well then x plus 6 isn't quite 0. It's close to 0. So let's see. If x plus 6 is close to 0, what does that do to the value of y? Well, it means we're dividing something up here, and we can plug in -6 and make sure that this isn't 0, and it isn't. So that we're dividing something that isn't 0 by something that is close to 0. Okay, something that isn't close to 0 by something that is close to 0. And what happens when you do that? Well, most people weren't able to really process that question. And this goes back to my soapbox about early and extensive use of calculators as opposed to understanding. Calculators can be used to build understanding, but most often they're used as an expedient tool to pretend that your students know something. And I don't fault teachers for that, I fault the curriculum. Okay, so we looked at a series of simple calculations here in order to get a grasp on how this behaves. And we'll continue this in another clip.